Welcome to all. I'm Surya. I'm working as assistant professor in Dr. S.N.S. Rajlakshmi College of Arts and Science in the Department of Computer Applications. So today we are going to see about stack and queue. First, what is a stack? So it is a stack of books. So here we have arranged some set of books, okay, in order. So what is a stack? A stack is a data structure of ordered items such that items can be inserted and removed only at one end. So what can we do with a stack? Push, peek and pop. So these are the three options we can do in the stack. So push means we can place an item in the stack, and then peek, look at the item on the top of the stack. For example, if 1, 2, third, fourth, in that order if we are keeping the book means we'll be seeing the top of the book but do not remove it. Pop, look at the item on the top of the stack and remove it, which is the topmost book is available in the first place, then we can remove it. That option is called as a pop. Next, stack. A stack is a last in first out data structure. For example, last in first out means if you are arranging the book means first whatever book we are keeping as a first, so it will be taken out as a last option. Okay. A stack is sometimes also called as a push down store. And then what are some applications of stacks? Program execution, parsing and evaluating postfix expressions. So next problems, what happens if we try to pop an item of the stack when the stack is empty? This is called a stack underflow. The pop method needs some way of telling us that this has happened. In Java, we use this java.util.empty stack exception. So interface iStack. So this is the example of interface iStack. And then using iStack, say balance of braces and then how many not balanced braces and how many balanced braces we can see. How can you use iStack to check a brace is balanced or not? So when you implement the above requirement, you ignore the implementation details of iStack. So implementing a stack. There are two ways we can implement a stack, using an array and using a linked list. So implementing a stack using an array is fairly easy. The bottom of the stack is at data 0, the top of the stack at the data's number items -1, push and the stack at the data and then pop off of the stack at data. So implementing a stack using a linked list is not that bad either. Store the items in the stack in the linked list. The top of the stack is a head node. The bottom of the stack is the end of the list. So we will be calling as head node, which is the top of the stack, and then bottom of the stack is called as the end of the list. Push by adding to the front of the list. Pop by removing the from the front of the list. And then how can we reverse the word? We can use a stack to reverse the letters in the word. How? So read each letter in the word and push it on the stack. When you reach the end of the word, pop the letters of the stack and print them out. So this is the example of queue. So who is coming out, coming first, they will be going out. So what is a queue? A data structure of ordered items is that items can be inserted only at one end and removed at the other end. Example, a line at the supermarket. So whoever is coming first, they will be buying the things and then they will be going first. What can we do with the queue? NQ and then DQ. So NQ means add an item to the queue. DQ means remove an item from the queue. These ops are also called as insert and get friend in order to simplify things. The queue is called as first in first out data structure. What are some applications of queues? Round robin scheduling in processors, input output processing, queuing of packets for delivery in networks. Implementing a queue. Just like a stack, we can implementing a queues in two ways. First one is an array and then second one is a linked list. So using an array to implement a queue is significantly harder than using an array to implement a stack. Why? So it is unlike a stack where we add remove at the same end. In a queue, we add to one end and remove from the other. So there are 2 points for implementing a queue using an array. First one, NQ data and then DQ data. The NQ at data of 0 and shift all the rest of the items in the array down to make room. So DQ from data. So option 2, NQ and then DQ. The real variable always contain the index of the last item in the queue. The front variables always contain the index of the first item in the queue. So when we reach the end of the array, wrap around to the front of again. So this is an example of queue. So today we have seen about stack and queue in the data structure. We'll see in the next video. Thank you.